Good morning to all of you. This is Somshekar, Assistant Professor of Mathematics, Sarami Government Science College, Pamunkate, Bhadravati. In this session, we are going to discuss about some different kinds of sequences. Let me have this problem. Test the convergence of the sequence whose nth term is this one. To test the convergence, we have to find limit value. Depending on the limit value, the behavior of the sequence depends. Call this nth term as Sn or Xn, whatever may be. Find the limit value. Limit of Sn is equal to limit of this one. Don't give limit value at this stage directly because we have infinity by infinity form, indeterminate form. To remove this indeterminate form, first of all, apply the sum of this numerator and the denominator. Numerator is the sum of squares of first n natural numbers, and denominator is the sum of cubes of first n natural numbers. From the number theory, we know the sum of these two. And we know that the sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. And the sum of the cubes of first n natural numbers is n square into n plus 1 whole square by 4. Please remember these two formulas. Now cancel the n value. Six for denominator ಇದೆ, 2 2s are 2 3s are. Now this 2 comes to numerator, so it becomes 2 by 3. n plus 1 in the n common ತಗೊಳ್ಳಿ, it becomes n square. 2n plus 1 in the n common ತಗೊಂಡಾಗ n square into n cube. n cube into 1 plus 1 by n into 2 plus 1 by n, and this is the numerator. And the denominator is n plus 1 whole square in the n common ತಗೊಳ್ಳಿ. Since a square is there, this n comes along with the square. So n square into n square, n to the power of 4 into 1 plus 1 by n whole square, and this will be the denominator term. Now n to the power of 4 ಅಲ್ಲಿ n to the power of 3 ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿಕೊಂಡ್ರೆ in the denominator we have n value. Now after giving the limit value, 1 by infinity is 0, 1 by infinity is 0, the numerator is 2. Anyway, if you give the limit value for the denominator, here n is there and this becomes infinity. Now any finite value by infinity is 0. Since we have unique finite value, the given sequence is convergent and converges to 0. Let me have this problem. 7 plus 3 into 5 to the power of n divided by 6 plus 4 into 5 to the power of n. Please note this point. When the base is greater than 1, that to the power of infinity is infinity. When the base is less than 1, that to the power of infinity is 0. Now at this stage, don't give limit value directly because here 5 is greater than 1, and therefore that to the power of infinity is infinity. Infinity by infinity form. Now we can remove this indeterminate form like this. 5 to the power of n, 5 to the power of n is the common term in both the numerator and denominator. Take outside. 5 to the power of n ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ 7 into 1 by 5 to the power of n plus 3 and divided by 5 to the power of n common ತಗೊಂಡಾಗ 6 into 1 by 5 to the power of n plus 4. Now 5 to the power of n, 5 to the power of n gets cancelled. We left with this term. Since 1 by 5 to the power of n, 1 by 5 is less than 1, and therefore that to the power of infinity is 0. So at this stage, give the limit value, and definitely we have a definite finite value. Now 1 by 5 to the power of n. After giving the limit value, since 1 by 5 is less than 1, that to the power of infinity is 0. So 0 into 7 is 0 plus 3 divided by, similarly 1 by 5 to the power of n. 1 by 5 is less than 1 and therefore that to the power of infinity is 0. 0 into 6 is 0, 0 plus 4. Ultimately we have 3 by 4. Since we have unique finite value, the given sequence is convergent and converges to this value, 3 by 4. 1 plus cos n pi. Please observe this sequence. Cos n pi has different values for different n values. When n is even integer, cos n pi value is plus 1, cos 2 pi, cos 4 pi, cos 6 pi. These are all plus 1. When n is odd, cos 1 pi, cos 3 pi, cos 5 pi, these are all minus 1. Since cos n pi has different values for different n values, we should see the limit of this sequence in two different cases. When n is even, the limit value of this total sequence is, when n is even, cos n pi is plus 1, plus 1 plus 1 plus 2. 2. The limit value of this sequence when n is even is 2. Similarly, when n is odd, the value of cos n pi is minus 1 and the effect on this sequence is minus 1 plus 1, 0. If n is odd, the limit value of this sequence is 0. Since we have two different values, our conclusion is the given sequence is oscillatory and oscillates between 0 and 2. While observing this problem, 4, 3, 2, 4, all the bits are greater than 1. And therefore, that to the power of infinity is infinity. Now we have infinity by infinity form. We can remove this indeterminate form like this. First of all, split 4 to the power of n into 4 plus 3 to the power of n into 3 to the power of minus 1 divided by 2 to the power of n into 2 plus 4 to the power of n into 4 to the power of minus 1. Numerator and denominator have the common term 4 to the power of n. Take outside. Four to the power of n comes outside. The remaining is 4 plus 3 to the power of n by 4 to the power of n. That can be written as 3 by 4 all to the power of n. 3 by 4 all to the power of n into 3 to the power of minus 1 divided by, and take 4 to the power of n common in the denominator. We have, after taking the 4 to the power of n as a common factor, we have 2 to the power of n by 4 to the power of n. That can be written as 2 by 4 whole to the power of n into 2 plus 4 to the power of minus 1. Now these two gets cancelled. Now give the limit value. 3 by 4 is less than 1. The base is less than 1. Therefore, that to the power of infinity is 0. So after giving the limit value, 0 into something is 0. 4 plus 0 divided by, again 2 by 4 is less than 1. That is why this to the power of infinity is 0. 0 into 2 is 0. 0 plus 4 to the power of minus 1 is 1 by 4. Therefore, ultimately we have 4 divided by 1 by 4. Now this 4 comes to numerator. 4 into 4, 16. Since we have unique limit value, the given sequence is convergent and converges to this value. One plus 2 by n to the power of minus 4n. Now we can bring this sequence into the standard form, into the standard sequence like this. We can write power like this, power n, power minus 4. please make some corrections. Power n power minus 4. But 1 plus 2 by n power n is a standard sequence. I already told you. The limit value of this is e power of plus 2. ಈ ಟರ್ಮಲ್ಲಿ ನ್ಯೂಮರೇಟರ್ ಪ್ಲಸ್ 2 ಇದೆ, ಇನ ಪವರು ಪ್ಲಸ್ 2. ಈ ಟರ್ಮಲ್ಲಿ ನ್ಯೂಮರೇಟರ್ ಏನಿರುತ್ತೋ ಅದು ಇನ ಪವರ್ ಇರುತ್ತೆ. ಇದನ್ನು ನಾನು ಆಗಲೇ ನಿಮಗೆ ತಿಳಿಸಿದ್ದೀನಿ ಇನ್ ದಿ ಪ್ರೀವಿಯಸ್ ಸೆಷನ್ಸ್. ಇ ಪವರ್ ಆಫ್ ಪ್ಲಸ್ 2 ಇನ್ ದಿ ಪವರ್ minus 4 is there, plus 2 into minus 4 minus 8, e power of minus 8, or 1 by e to the power of 8. And definitely, and this is a unique finite value, so the conclusion is given sequence is convergent. Let me have this problem, and this is exactly similar to the first problem. Find the limit value, and before finding the limit value, first of all find the sum of both the numerator and the denominator. I already told you the sum of squares of a first n natural number is n into n plus 1 into 2n plus 1 by 6, and divided by the sum of first n natural number is n into n plus 1 by 2. Now n into n plus 1, n into n plus 1, these two gets cancelled. 2 1s are 2 3s are, this 3 comes to denominator. Ultimately we have 2n plus 1 divided by 3. Now give the limit value. In the infinity by 3, it will be infinity. Since the limit value is infinity, our conclusion is the given sequence is divergent and diverges to plus infinity. Here is another problem. First of all, find the sum of the numerator. The sum of first n natural number is n into n plus 1 divided by 2. This 2 comes to denominator, and in the denominator take n square common. The remaining is 2 plus 3n by n square. 1 n gets cancelled, 3 by n. Now take n common in the numerator, n into n square, this n square gets cancelled. Ultimately we have 1 plus 1 by n divided by 2 into 2 plus 3 by n. Now give the limit value. 1 by infinity, 3 by infinity, 0. 1 by 2 into 2, 4. 1 by 4. Since we have unique finite value, conclusion is given sequence is convergent. And please go through some other problems. And if you have any queries, follow these references. Thank you one and all, and see you in the next session.